Today, what we're doing is we're talking about optimization problems, okay? Optimization means, in a sense, to find the best, to optimize, right? So whether it's the best as far as a maximum volume, minimum cost, maximum profit, right? Maximum volume, those are like optimizing, to find the very best, right? So in every one of these, when you do these problems, first of all, just start with a picture. So you find a picture, then you try and figure out some kind of formula that goes with the picture, okay? Whether it's area or perimeter, right, or volume. I mean, those are the things you can look at, okay? Once you get those, then you figure out what you have to maximize, okay? We can do a couple of different things. We can maximize from our calculator by graphing it, right? That's one way. If it's a parabola, we can use the negative b over 2a. That's another way. So, or same thing with a minimization. We can either use the calculator, or we can use, if it's a parabola, we can use the negative b over 2a. So let's start with example 1, okay? So a rectangular pen used in a barn wall for one side is constructed using 100 meters of fencing. Find the dimensions of the pen that will maximize the area and find that area. Okay, so let's just start real quick, like drawing a picture. So I'm going to put my barn here. So being a smart farmer, why not just use the barn as one side of the fence, right? And then the cows can come in and out, and I can put the fence around it. I'm going to construct a rectangle, all right? It says rectangular pen, so I'm just going to kind of draw a rectangle here. And that would be my fence. Okay, so let's start there with at least a picture. Now the fencing is going to go on all three sides because the barn becomes the fourth side. If it is a rectangle, one of the things I do know is these two sides are going to be equal. So we can call this, say, W for width, or you can use X, but I'll use W. You can use X. I'm just going to use W for width, okay? We're going to use 100 meters, right? And within the 100 meters, if we put some of it here and some of it here, what's left over, we have to go here, right? So I always say, okay, if this is 10 and 10, that'd be 20, we could put 80 here, right? If this was 20, 20, that'd be 40, we'd have 60 here, right? But we don't know, so this is going to just be my 100 minus these two pieces of wire, which is a 2W, okay? Now, I've got my picture. I have it labeled with variables. Now the next thing I'm talking about is to maximize the area. So if I have to maximize the area, the formula I'm going to use is the area formula. So I'm going to go straight to, some area is equal to, length times width, or in this case it's W times 100 minus 2W. I'm going to write it in function form. Okay, I'm going to write it in function form. I'm going to go area with respect to W, A of W. Area with respect to W is equal to, and I'll distribute 100W minus 2W squared. All right, so all I did is area is length times width, that's my W times my 100 minus 2W. I've simplified it by making it 100W and minus a 2W squared, and I like it in function form because it really is the area with respect to the width, okay? Because whatever you make this width, it changes the area, doesn't it? So it is all dependent on the width. That's what it means, area with respect to width. Now, if I want to maximize it, what I do know is a couple of things. I could graph it, and it would be a parabola, and I'd want to find then obviously where the maximum is. Or since it is a parabola, x squared, I can use my formula, and I can use my negative b over 2a. Okay, since it's an x squared, I can just use that negative b over 2a, okay? So a is my negative 2, and b is my 100, because a is always the coefficient with the x squared term, and b is always the coefficient with the x term, okay? So we'll do a negative b, which is our negative 100, over 2 times negative a, which is negative 2. So I'm just using my formula, negative b over 2 times a. So I've got my negative 100, 2 times negative 2, which should make a 100 over 4, right?
Negative 4.
They're both negative, so I cancel negative. Great, thank you, Marie. Always try and find my mistakes, which is going to be 25. Okay, so what does that mean? What did I find? Found the width, didn't I? And that's why I like to use the right variables, because I found the width. So W is 25. So let me go back to my figures. Okay, well here's what I know. All right, let's go back, and I know this side's going to be 25, right? This side's going to be 25, which makes the length 50. Do you agree with 50? Because I've got 100, 25, 25, and I'd have 50 left over, okay? So how big is this barn? What's the area? Well, if I wanted to find the area, then that's not too hard. It's just 25 times 50, right? How big is this barn? Well, let's find out. 25 times 50. Okay, 25 times 50 is going to be 1,250, and that's in terms of meters squared. Okay, now, before we go to the domain, let's think about the problem. This is the way we want to build our fence, okay? But you could build it in lots of ways. You could make this 1 meter and this 1 meter, and you make the whole thing 48 meters long. I don't think very many cows are going to fit in that, right? It's going to be a tight squeeze, right? But we could build that barn. We could do it the other way. We could make this 48 and this 48 and make this width 1 meter. Not a very good barn though, right? We have a hard time getting the cows in and out. So there's all these possible ways to build this barn, but for us, the very best way to get the most out of our fence is to make it 25 by 50. Okay, that maximizes it. So what about the domain? The domain's talking about the x variable, right? So the x in this case is our width. What's our domain? Is width. And it's all possible widths. All possible widths. Okay? So I've got this barn. I can make it in lots of ways. Now there's some really bad ways to make it, but I could make it this way, right? What's the smallest the width could be? What's the smallest this width could be? It could be 20. It could be smaller than 25. I could make it 10 even, couldn't I? 10 and 10. It wouldn't be the best barn, but I could make it, right? This is the best way to make it, but I could make lots of barns. I could make it 5 and 5, right? I could make this width. How about up to 0? Not exactly 0. So we're going to say the domain has got to be greater than 0, which means it could be an inch. That'd be a really silly barn, though, wouldn't it? But it's possible to make that rectangle. You could make it 1 inch. You could make it half an inch. It'd be a really dumb pen, but we could. That's a possible way to build this. What's the biggest our width can be?
Less than 100.
Less than.
I heard it. Say what? Did you say 50? 50, because you got 50-50 on both sides, right? Width, 50-50. But I can't actually do 50, because if I do exactly 50, I don't have a rectangle, right? So let's just make the width be less than 50. So it could be 49 and not 49 feet and 11 inches, or 49.9 meters, or whatever. So that the width is talking about what are all the possible ways to do it. Okay. Now, if you graph this thing, okay, if you did graph it, I'll show you. Y equals clear, and if I went the 100 x minus 2x squared, and the window I'm going to do, I'm going to take a little hint from my domain. I'm going to go from 0 to 50, right? I'll go a little bit bigger so you can see it. And my maximum, I know my very biggest is 1,250, so I'll probably go, let's go 1,500. And if I graph this, I get a curve. What does a curve represent? You go to your trace. If my width were 27.5, my volume is 1,236, okay? And you just go along. If my width was like 40, my volume is only 777, right? So it shows all the possible widths and all the possible volumes, okay? And if you think about domain as how wide the graph is, the graph goes from 0 to 50, doesn't it? Okay. Where's our maximum? Right up here. And so if our maximum should be at 25 and 1,250, right? Right about there. What do you know? 25. There's our maximum, right? And I could do my calculate max, right? There you go. Enter. Enter guess. Let's see what the calculator does. Calculator agree with me? Heck yeah. Of course, it goes 24.9999999.
Which is pretty much
25, yeah, because remember the calculator never does math. It just looks for answers, right? Okay, thumbs up on that problem. Not too bad. Okay, let's look at example 2. Okay, now, example 2, farmer needs to do the exact same thing, but this time we need 2 pins. Because this time maybe we got cats and dogs, or chickens and ducks, cows and horses, whatever, but we need to do 2 pins. So, let's try and draw a picture. Here's my barn. Okay, here's my fencing. I'll put another fence there. Now, here's something that we need to know. To make 2 adjacent, we'll need a piece of fencing here and here. We'll need 3 pieces of fencing, right, to make 2 adjacent barns, right? They don't have to be equal. They do not have to be equal sizes. We just need to maximize the rectangle, okay? I mean, maybe cats be a little bit smaller than the dogs. I mean, if it was me, I'd make the cats about this big and the dogs really big. But, you know, I'm not a real cat lover, so anyway. But for sure, rectangle. We'll go W, W, right? And we'll put W here also. So this time we have another piece because we need to make 2 adjacent fences, right? So this is going to have to be 100 minus 3W because I'm still using the same 100 meters of fencing, right? Because it makes sense, the 3 W's, because you need 2 fences. So area is going to be my length times width. Okay. Same kind of problem, really. It's just a little bit different. I'm going to make it a function, area with respect to the width, A of W. Area with respect to the width is equal to a 100W minus a 3W squared. Right? Again, it's a parabola. You can graph it to get the answer. I'm just going to use my negative B over 2a because it's faster for me. Since it is a parabola, I can use my negative b over 2a. Here's my b, and here's my a. So I'll go negative 100 over 2 times negative 3, which is a positive 100 over a positive 6, which should be, I think it's a 33 1/3. I think it is. 100 divided by 6. No, 16 2/3. I was wrong. Glad I checked. So I got 16 2/3. What is that? What is that number? That's our width. It's our width, right? So that's our width. That's W. So if I went and said, okay, I'm going to make this 16 2/3, 16 2/3, 16 2/3. Let's see if I multiply that answer times 3. I got 50, so I've used up 50, 50. So if this is 50, so this would have to be 50 also, right? If I've got 100. This plus this makes 50. This plus this makes 15. So I'd have 50 left over for this piece right here, okay? So 50. So if I built my fence in this fashion, I'd maximize my area, okay? Domain. Domain's the width. 0. Easiest part's 0, right? I mean, because you can make it all the way down to 0. This could be, I mean, this width could be down to 0, right? So I'll go width, domain is 0, right?
So wouldn't it be 50?
Well, if I put 50, 50, 50 here, it'd be over, right? So if you put all of your pieces in these 3 pieces, if you took your 100 meters and divided it up into 3 parts, you'd use all of your fencing, right? And you wouldn't have anything left for here, but you could do that. That'd be 33 1/3. There you go. But you wouldn't exactly make 33 1/3 because then you wouldn't have anything left for the width, for the length, right? And it wouldn't be a rectangle. So all the domain says is, what are all the possible ways to build this fence? I'm not saying any of these are very good ways, but these are ways you could. It'd be kind of a silly fence to have it super little and super skinny, right? Or super wide and super narrow. Not a good fence, right? Brooke, you wouldn't put your horse in any of these, would you? You'd probably put your horse in that one, huh? Yeah. Give it as much room as you can, right, Brooke? Okay, you ready for the next one? Turn the page. All right, a physics problem. All right. So an object is thrown from a 20-foot building with an initial velocity of 19 feet per second the equation of h of t is equal to 20 plus 19t minus 6t models the height, okay? Now, gravity in feet is about 16t squared, but, or velocity is 32. You guys are doing physics, it's about 9.8, right? Now, that's only if you drop something in a vacuum, right? If it has a lot of wind resistance, it might be a big beach ball, right? So that's why this number is different, because it could be a beach ball, which certainly isn't going to fall very fast. So this particular object. So how many seconds does it hit the ground? All right, well, what does that mean? When it hits the ground, what's the height? 0. So if I say, okay, 0 is equal to 20 plus 19t minus 6t squared. All right. Let's solve for t. Any ideas? It could factor. Yeah, it could factor. It could factor. Well, it might factor. I'm not sure. I'll try it. 3t, 2t, I'll try 10, and 2, maybe there's a 30 and a 4. Let's try a 4 and a 5. That's a 15 and a 10. You know, I'm not sure about factoring, but I do have another way to do it. I like the poly button. That's my favorite way. Honestly, if I can't factor it, if I'm stuck, I'll just use the poly button, okay? Or you could graph it and find the 0, right? So I'm just going to go to, remember my poly button? At poly. Remember doing the poly button? Guys, remember the poly button at all? Poly root finder, order 2. I'll go -6, 19, and 20. And Will, if I get good answers, then it would have factored, right? Solve, and you know what, it does factor, but obviously I didn't factor it very well. So I get 2 answers. I've got t equals -0.83 and t equals 4. Okay, now, one of those 2 I'm going to throw away. Yeah, it can't be negative time, right? I mean, the darn thing can't land before I threw it. I'll say it again. The thing can't land before I threw it. So you throw away your negative time, right? So in a sense, it's going to look something like this, right? And at 4 seconds, it's going to hit. How high does it go?
Starts from 20 feet.
Well, let's use our negative b over 2a for that. So I want to maximize, look for the maximum. So I can use my negative b over 2a for the maximum height, right? That's my vertex. So I can use my -19 over 2 times -6, which is 19 over 12, and I don't know what that is. I'll tell you in a second. 19 divided by 12,
1.58.
about 1.583. Now that's the time. So think about the problem. We throw it up in the air, and at 1.5 seconds, it's at its highest height. Okay? What is that height?
Plug that number.
Plug it in. Yeah, so plug it in. So when I plug it in, I'm going to take my h of 1.583. It's going to be my 20 plus 19 times my 1.583 minus 6 times my 1.583 squared, right? And now I'm going to let my calculator do all that. Since I already have this in my calculator as my answer, right? As my answer, let the calculator do the work for me. So we're going to go ahead and go our 20 plus 19 answer. I like that answer button, right? Because then I get all of those decimals. Minus 6 answer. Oops, let's back up. Answer squared. Go to. Didn't like it. What did I do wrong? Oh, it doesn't like this. That's supposed to be that. Okay, now. So I get about 35. About 35 feet high. Okay, now, domain and range. Domain and range. Okay, domain is the x value, right? Domain's the x value, but we don't have an x value. What is our x value? It's called a t, right? So it's our time. Greater than 0, but less than 4, okay? So domain is, okay. Now sometimes Mr. Massey and I might disagree on this. He might include it. In physics, he'll say at that moment it is stopping, so therefore it has motion. I say no, it's on the ground, so it's not moving. I don't care if you put an equal there or not. Here, if you haven't, time hasn't started, it hasn't moved, so I've, you know. Okay, now what about range? Reach for your range.
0 to 35.
Yes, it is, and now those are equal. Okay, 0 is less than or equal to h of t less than or equal to 35. Nice job, Will. And it does equal 0. When it's on the ground, it has a height of 0, and when it's its highest spot, it's at 35 feet. Good job. Okay, so that's what I got for you today. Okay, not too bad. Now the homework is a worksheet, which I'm going to